Hi and welcome to the 28th session of Physics 9. This is Sir CJ, and in this session we have the following parts to finish. The first part is a discussion, other gather information on gravitational potential energy. And then that is going to be followed by guided problem solving on a sample problem on potential energy, particularly on gravitational potential energy. And then the last one, you will be solving this problem by yourself. It's an independent problem solving activity on a problem on potential energy. Again, particularly on gravitational potential energy. So yes, it seems like this session we're gonna be focusing on one kind of potential energy, and that is, gravitational potential energy. The learning competency that we are targeting in this session is as follows. So by the end of this session, you should be closer to being good at explaining energy transformation in various activities or events, such as in waterfalls, archery, and amusement rides. Ayan. So this is based on the 7E based self-learning module in Science 9, which I wrote, particularly in Unit 4, Book 21, pages 3 to 15. So yeah, let's dive in. For the discussion on under gather information about gravitational potential energy, remember that you have been introduced already to the concept in the previous video lesson that potential energy is actually getting affected by the position of an object. Okay, so when the consideration is the position of an object, its relative position on Earth, that is, we are actually kumbaga being concerned about its potential energy. Okay, particularly its gravitational potential energy. Um, the position we are referring to in this case serves as the reference point. And remember that at this point, reference point, it's not actually, parang nag-move siya from one point to another. It just has one reference point. Now, this reference point is a point in space where the object that has that gravitational potential energy is located. Now, usually, the ground is the reference point for zero gravitational potential energy. So, when the object is put at on the ground, that is like the lowest point at which they can go, the gravitational potential energy could also be equated to be zero at that point. Now, gravitational potential energy is something we can solve for. We can actually compute kung gaano ka-taas ang gravitational potential energy ng mga bagay. And we use the following formula. So, yeah, the gravitational potential energy, or PE gravitational, or we can also use PEG, is equal to the mass multiplied by the acceleration due to gravity multiplied by height. Okay? Now, mass is symbolized by m, the usual symbol for mass. Acceleration due to gravity, which is 9.8 meters per second squared, as you may already know since our projectile motion days, is symbolized by g, that's lowercase, pareho sila ni mass, na lowercase. And then height is symbolized by lowercase h. Now, the mass of the object in these problems should be reported in kilograms as much as possible. And it has to be multiplied by acceleration due to gravity, which is a constant and is equal to 9.8 meters per second squared. And then it's multiplied by the height, where the object is located, expressed in meters, or m. Now, we can actually have different kinds of units na gamitin in solving these problems, pero I hope that you get that we are just trying to make this uniform muna while we're starting to understand them, and maybe after a while when we are showing competence already, we can switch things up. Now, the resulting unit must be in kilogram meters per second squared meter. So, di ko lang siya na-bold dito. Okay, pero it's actually kilogram meters per second squared meter, that's m, which is actually equal to Newton meter. Now, to know more about how this physical concept works, we have to consider the next sample problem. Okay, so again, ang kinaklarify natin dito, ano yung formulang gagamitin, at ano yung mga units na in-expect nating magamit, and also the unit of the gravitational potential energy which we are going to get. Yeah. So we're done with the first part of this session. Let us now move forward to the next part. In this sample problem, we are going to have, a guided problem solving, and ang pinaka-focus natin dito is to help you out in solving your own problem in the future, and by saying future, later. Okay. Now, in this problem, it says that Aaron filled a pitcher with water, then placed it on top of their dining table. Now, the pitcher is 2.4 kilograms and is standing still on the table 1.2 meters above the ground. Now, how much potential energy does it have? So I want you to first, on your answer sheets, on your scrap papers, write the givens that you see on this problem. Are you done? Now let's see if you have the following givens. So for the mass, it's 2.4 kilograms. And then for height, it's 1.2 meters. So as you can see, there's no need for some kind of conversion because these units work for our requirements. And then di man siya nailagay dyan. Pero remember that in the formula included ang G, which is acceleration due to gravity, and it is equal to 9.8 meters per second squared. Now, the thing that we are looking for is potential energy, particularly gravitational potential energy. Alright, so do you have these givens? I hope that you have them. I label them properly and make sure they have units. Alright, let's proceed with the solution. The solution starts, of course, with the label solution, and it starts with the base form of the formula. Remember that if the base form of the formula is not actually going to parang isolate the factor we're solving for, I suggest that you derive things first so that when you put the numbers, hindi na siya gaanong nakakalito. Okay, so I really suggest you do the derivation before you plot or you substitute the givens. Okay, so look at this formula. Since we are looking for the gravitational potential energy, there is really no need for us to derive any more formula. Okay, so this is already going to work. Alright, so the next thing we're gonna do then is we will be substituting the givens. So 2.4 kilograms, that's for the mass. 9.8 meters per second squared, that is the acceleration due to gravity. And remember that the pitcher is 1.2 meters above the ground. So the table is actually that high. Now, you carry out the operations. Okay, so remember, you multiply this by this and then by that. And then you have to also show how your units are gonna adjust. Alright, so box your final answer. What did you get? Did you get this one? Okay, so I hope that you did get this correctly. Okay, I hope that you got this correctly. The resulting potential energy should be 28.224 Newton meter or 28.224 kilogram meters per second squared meter. Okay, but when we're reading this, I think it's 28.224 thousandths, 200, parang 224 thousandths, right? Alright, that's how we read decimal numbers. Yeah. So that is how much gravitational potential energy you'll find dun sa picture. Alright, now it's time for you to do an independent problem solving activity. Are you ready? I want you to pull out a clean sheet of paper and answer the following question. Solve the following problem. Now, right after Aaron filled the pitcher, his sister Alexis took a glass and filled it with water. The pitcher's new mass is now just 1.9 kilograms. So medyo marami yatang binawas si Alexis dun sa tubig na nandun sa loob ng pitcher. Now, Alexis returned it to its original position. So we are assuming that it's the same table. Okay, so original position. So yung table, kung meron man siyang higher parts or lower parts, it doesn't matter because it was returned on the same height. So it was also the same height that we used in the previous problem. Now that it's quite lighter, how much gravitational potential energy does it have now? So you can now start writing the givens to this problem and refer to the previous problem if you need to. Anyways, you're just gonna need the height dun sa previous problem. But I think you still remember it. Now, make sure that you label your givens and that you label the solution. You also start with the base form of the formula. And remember to derive a formula first before substituting your givens, of course. Now, are you through? You can pause this video if you need more time. Are you done? All right. Your answer should be 22, I mean 200. 22.344 Newton meter, or it's 22.344 kilogram meters per second squared meter. Ayan. And then it's also read as 22.344 thousandths Newton meter worth of potential energy, particularly gravitational potential energy. Did you get this correctly? I hope you did. All right. Let us now finish up. Okay. So in this session, you were introduced to the fact that an object has potential energy, and if that potential energy is relative to its position on Earth, it is referred to as gravitational potential energy, and we already discussed that. Now we put that concept into application through a guided problem-solving activity, and I gave you a very similar problem to solve for in an independent problem-solving activity on gravitational potential energy. Now, remember that this session is under the Unit 4, Book number 21, pages 13 to 15 of the 7E based self-learning module in Science 9, which I wrote. And then we are also targeting pa rin the learning competency explain energy transformation in various activities or events, such as in waterfalls, in archery, and amusement rides. This is Sir CJ, and I am hoping that you indeed learned something in this video lesson, and that I will see you in the next video lesson related to the next kind of potential energy. Have a good day.